Hello everyone, welcome again in Python tutorial for data mining and data analysis. At this time, we would like to extend our solution method from scratch coding into a more advanced coding by using a spatial library called it and it is called Sklearn library. And you could find the tutorial of the Sklearn library from Nelly. I give you the source here. You can get from our library. There is a ebook written in our library. You can find the title of the book is Python Data Analytics and Data Analysis and Science using Pandas, Matplotlib, and the Python programming language. And before starting to get to know about the library, sklearn library, I would like to remind you again about the process of analyzing data by uh, by using predictive modeling. Uh, the system has the input coming from outside data. It can be from marketing departments, can be from production departments, provide raw data or maybe pre-processed data. So any kind of data can be inputted into the systems. And we will start with data extraction. Uh, this data extraction process it takes about 50 to 70% of your time to in during the data analysis process. So in data analysis process, most of the time spent is for extracting data and make it data ready to be processed by using machine learning algorithm. So in data extraction, after you extract the data, you need to prepare the data. And Python start the process of analyzing data from data preparation, exploration, predictive modeling, and model validation. Also deployment of the data into to anyone or maybe any system in the organization who would like to use the result from the data analysis. So uh, in data preparation, there are some steps or processes need to be done. For instance, you need to extract the table or maybe grabs from the from outside sources, and you need to exclude any outliers. I would say outliers. That is a data that is not fit to be processed by the uh, Python libraries, machine learning libraries. And after you prepare the data, you need to make a data exploration where we need to analyze a little bit of data by using some kind of like tools. Uh, just for instance, calculating the mean and standard deviation of about the data. And in this case, you need to get to know how to get or the information by using Python library. And after you got or you visualize or you explore the data, you start using predictive modeling. So machine learning actually intended to uh, to this stage in predictive modeling. So after the result of the or the outcome of the machine learning need to be validated, and the validation also happen in the machine learning algorithm as well. And from the machine learning outputs, uh, we can deploy the result and use or maybe interchange the data to other software, for instance like Microsoft Excel, so that the data can be presented in a better way with a more what is say more user friendly. So everybody which who are not really familiar with the machine learning can get the message, or maybe can get the conclusion, or maybe the result, what is data telling about. And all right, last week, sorry, in last session, I promised that we will not anymore use that kind of scratch uh, coding to produce, or to get, or to deploy result from predictive modeling. And therefore, this time we will use Sklearn, and we can start to use Sklearn by installing the library into our Python. All right. So now in front of us we have a blank screen of Python. Here I'm using a Spider to uh, to write my code. And as usual, I would like to import some libraries. For instance, NumPy as NP, and from sklearn, I would like to import support vector machine. So before we do not use support vector machine library, because we would like to create optimization from scratch. But here we do not need to make optimization, because support vector machine library have everything tools necessary to find the answer. And also from sklearn dot model dot selection, we would like to import another library. It is named train, and then test and split. So the library basically replace our previous function definition that we made in our support vector machine um, code in Python that we have already discussed before. So in this kind of uh, code writing, we do not need to we do not need anymore to write our own function to make to split between uh, uh, test dataset and train datasets. So it is already done by sklearn model selection. And okay, now we can start import another good, maybe easy use library called pandas. Pandas actually is a library um, which is used for making some kind of like descriptive analytics. And pandas is very useful, because whatever the type of your data, it is can be float, numeric for instance, or maybe it is the data is categorized as a non-numeric. Panda will recognize those. It is quite different to NumPy. In NumPy, only data that is numeric can be read by the library. But in Pandas, you can use any kind of data, right? Okay, now we need to load uh, the data into Python. So we can write here the CSV file. All right, by using data frame. But I just try to make easy to read, like DF. It is like abbreviation of data frame, or you can put any name like data or something, or maybe data set. But be consistent. So data frame I define as a data coming from from the data source. Read CSV, and I would like to take data from, sorry, Python from this file, CSV file. What is the name of the file? Python data file for class Excel exercise classification. Okay, quite long, but no problem. We can write. All right. Now I have defined my data as a Python data file for class Excel exercise classification 2, which is I put inside my Spider folder in my computer. So first of all, in order to be more familiar with the pandas, let's start to make to print the first 5 rows in the table. Or maybe we would like to print also the last 5 rows. It is called tail. And we would like to see any like outliers, and would like to exclude those outliers from our data analytics. So here we have data frame equal to data frame replace. So we could use this question mark, mean data which is not recognized by the panda. And we could put using numpy and an, means we could put any number that is really big enough so that it will be excluded or maybe ignored by the panda. And we could drop the value, sorry, drop name means drop non NA means like unrecognized data or something, some kind like that. Because most of, for instance, if you it is quite familiar in tabulation that if you do not recognize a cell or a data contained in such a cell, usually they are written as a NA in Excel. So that's why we should drop any NA values in the table, in the data set table. And then because we would like to classify uh, our independent variables so that it can uh, be correlated with the dependent variable, here we have x1 to x7 is are the independent variables, and y is the dependent variables. We need to tell the pandas which one is the dependent variables and which are the independent variables, and therefore we have to write x equal to df with data frame. So for instance, here we need we would like to change by df1, and then all here you should change by df1, 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 or df1. All right, but it can be any name. It can be df, can be df1. Okay, let's back to the original name as a df. Df dot drop. Sorry. Yes, drop, because we would like to exclude the header of the of of at the first row, because the first row contain the header. Here the first header name x1, and therefore we have to drop x1 so that it will not be counted by the pandas. So here we have to put x1 comma and then x is equal to 1. uh, Why x is equal to 1? If x is equal to 0, it represents the column. So x is equal to 1 in Python, it represents the rows. So x is equal to 1 is the rows. X is equal to 0 is the column. And y, we have to define and tell the pandas how to find the y or the dependent variables. So data frame, and then we have to put the bracket, another bracket. Uh, it is y. Yeah, another bracket. All right. So the question is that why we need to put another bracket here. We have two bracket within bracket, because pandas can recognize, for instance, like more than one types of dependent variables. For instance, in regression, which the outputs contain about more than one dependent variables, for example y1 and y2. Then we can add here y1 and y2 by putting comma and y2. So that's the uh, the intention why we need to put bracket within bracket. And now we have to tell the sklearn uh, what is the rule of the game in order to make this classification. And therefore we have to give this kind of syntax: xstring, comma, uh, and then xtest, ytrain, comma, ytest. It is equal to train, test, and split. And what is the, yeah, because we have import train, test, and split library. So here the function is just represented by one line of comment. So we put here all variables include into the computation x and y, and test size means how much the percentage or fraction within the data set can be used as a test data after we develop our um, develop our learning by using 75% of the data. And the random state equal to 1. Random state equal to 1. It can be also 0, but here we have equal to 1, means the sklearn will pick randomly data 75% from the data set and pull them into one set of train data, and also pick randomly the rest of it, or 25% of the data, and put as a test data. So here we have a random state equal to 1, mean we would like to make some kind of like uh, normal distribution, and how to pick the data. And for the first computation, we would like to implement support vector machine classification here. That is the first method that we use before, and therefore we have a CLF. It is called classification, but again, this name is free. You can put any name, not only CLF. But CLF here means classification, and SVM dot support vector classification. And here we have kernel. Kernel is, sorry, linear kernel. Means we are now implementing linear classification instead of nonlinear classification. And we have to check here, we have one invalid syntax. Oh yeah, the test size we need to put 25% of the data will be used for test. And okay, now we can continue. Okay, so we still have the error message here. All right, now we can continue. That C equal to 1.0. C is the penalty function here. So whenever the classification made mistake, then suddenly the optimization of the optimization model will give penalty about 1.0. And the next step is the classification. CLF dot, we have to fit between X and Y. Each row of independent variables to its dependent variable Y. And, oh sorry. Finally, we can measure the result, or we can get the result from this support vector machine classification by print the score of the classification by taking data between X test and Y test. Okay, that's this simple. Okay, now we can start to run this code. Yeah, I think we need to give a name. Okay, let give a name like Sklearn. Do not forget to put pi here, otherwise you cannot run the model because it will be saved as a text instead of Python files. Okay, no module names sklearn model. Okay, now we have to solve, which means I have to install the sklearn model. All right, now I have please keep in mind that never made a mistake in writing this from sklearn dot model selection import train test and split. Okay, now we can start to run the model. So what we get here is that because we print data frame head and with this without any number within the parenthesis, means automatically the panda will take or will pick the first 5 rows in the data set and showing onto the computer screen. And similarly, tail also five the last rows in the table. And the important result here is that the scoring, we have 1.0 score, means the model is enabled to identify correctly 100% of 100% correct. So from 25% test data, none of the data has been mistakenly identified or classified by the model. So it is quite easy to use, and I suggest you to use this sklearn. For instance, if you already know how the algorithm of the support vector machine. In order to get uh, to be familiar with the Sklearn support vector machine, I suggest you to visit this website. And within this website, you can see so many functions that you can use, and you can modify the model according to your needs by using this function list in the Sklearn support vector machine website. So here, how to write. There are also some example here you can use, and yeah, that's it. So you can imagine how many lines you can save uh, by using this sklearn support vector machine classification. Next time, for instance, if you would like to change the classification method by using, for instance, naive Bayes classification. Okay, for instance, now we would like to change the data. I mean the algorithm from a support vector machine into a naive Bayes classification. So we need another library, what we called sklearn dot okay, what is it? Naive, yeah, naive. Sorry, naive should be not in capital. Hey, why don't not much? Dot naive Bayes. I'm sure it should be here. Naive Bayes. Oh yeah, this one. Naive Bayes. Yeah. And depending on what kind of the classification model, if you would like to use a Gaussian, because our our data is continuous variables, therefore we need to use a Gaussian naive Bayes classification. And using the same data, we can use also the same train test split function from sklearn classifier. Uh, we should change the function of CLF, not anymore depending on the support vector machine. Rather, we can use CLF. It is equal to uh, Gaussian MB, and yeah, this one. And we can start to run the model if there is no any more additional comment that we need to. Let's check one by one. Yes, we have Panda, we have sklearn naive Bayes. Yes. Okay. For this time, let's start to make the classification by using naive Bayes. Exactly. Now we can get the result from naive Bayes, and the same. The naive Bayes classification give 100% correct prediction here. And there's another uh, interest thing, interesting result that we can extract from the data set. That is the cross validation here. So instead of printing the score, why don't we try to measure the score of, or the accuracy of the, or maybe accuracy is equal to, sorry, equal to uh, cross validation score CLF comma X test comma Y test comma CV equal to 5. CV equal to 5 means we have a 5-fold cross validation. So we validate 5 times. So we pick data randomly 5 times, and to see how much the accuracy of our data, of our analysis using cross validation score. However, in order to make this cross validation, we need to import another library for cross-validation from Sklearn dot model selection, yes, and we have to import cross validation score. All right, now we have everything on the table, so now we are ready to make the computation using naive Bayes, as well as to measure or as well as to validate the result of the computation. All right, yeah, we still have 100% correct about the result, and now we can start to start again to solve again, and we have, however, we cannot get the accuracy result, and therefore we have to print the accuracy. Here, let's start again. Yeah, we have 5 volts validation, and all of them are equal to 1, means the the uh, the sklearn has been successfully identified the dependent variable exactly as it is as listed by the data set. So here we have 100% correct. So it is its validation step result in 100% accuracy. And if we would like to change the model into random forest, it is very simply just put uh, another sklearn model. What we need to do here is that because random forest is some kind like an ensemble classifier, and therefore we have to import the ensemble classifier from sklearn library. Sorry, sklearn dot ensemble. Sorry, dot ensemble ensemble exactly ensemble. So we have to import random forest classifier, and also from the ensemble classifier we have now also train and test split, also cross validation score. And what we need to do is that we have to change a little bit the CLF, not using any more Gaussian and B, but we could use CLF equal to yeah, random forest classifier, and we have here n, yes, estimator and estimator equal to okay, let's say we pick 10 samples from its baking. From each sample or its bag, we take only 10 samples. So here we have n estimator equal to 10 and maximum depth. Okay, maximum depth is none. Let's say this none means we let the splitting to reach its terminal point, regardless the length of the or the number of nodes within one branch. And the minimum samples for uh, such a certain splitting point equal to 0, equal to 2. Yeah, this is a termination qualification. So for instance, if the rest of your rows which are not yet analyzed by using naive by using uh, random forest classifier is less than 2, then it will be terminated automatically or a stop. And the random state equal to 0. It is related to how we pick samples from a population or sample population within each bag during the bagging process. And yes, now we have everything here. Okay, let's see the result. All right. Yeah, same. We have the same result. We have 100% accuracy, and the result uh, after making 5-fold or k-fold cross validation, we found that for each fold of the sample has 100% accuracy in prediction. So I think this Sklearn is better, a bit better than our own scratch code that we just developed last time. Okay, so now you can see that by using Sklearn, it can save your development time. You don't have to think about the method, about the algorithm, how to do with it. But my suggestion is that before going into this some kind of, I call it the professional way to do the machine learning, I think you should be able to understand the mathematical background or statistical background behind the method. So that will give you a better understanding, and maybe if you find some kind of like problems with your computation, you can trace back the error and make some fix. You can fix the problem by yourself. Okay, I think this is another way how to solve the classification problems, and this is also the end of my tutorial video for classification. So next time we will try to continue with other videos in some kind like other use of machine learning, for instance in regression. Okay, so thank you for your attention, and see you again in the next in other topics of machine learning. Okay, goodbye.